Welcome to What Is. Today, we're tackling the big one, the grandfather of physics. The reason your GPS actually knows where the nearest Taco Bell is, and the reason why time is, quite literally, a hallucination. Today, we're asking, what is relativity? Now, before your brain tries to exit through your ears, don't panic. We aren't going to spend 8 minutes staring at chalkboards full of Greek symbols. Einstein didn't figure this out by being a mathbot. He figured it out by daydreaming about riding a beam of light. So, grab a coffee, sit back, and let's get weird. First, we need to clear something up. When people say relativity, they're usually talking about two different things: special relativity and general relativity. Think of special relativity as the speed prequel and general relativity as the gravity sequel. Let's start with the special stuff. Way back in 1905, Einstein realized something annoying about the universe. He realized that the speed of light, roughly 300,000 kilometers per second, is the universe's ultimate speed limit. Imagine you're on a train moving at 50 miles per hour. If you throw a baseball forward at 50 miles per hour, someone standing on the side of the tracks sees that ball going 100 miles per hour. Simple addition. Grade school stuff. But light is a diva. Light doesn't play by those rules. If you're on a spaceship going 99% the speed of light and you turn on a flashlight, you don't see the light crawling away from you. You see it zip away at exactly the speed of light. And the guy standing on the planet watching you go by, he also sees the light moving at exactly the speed of light. How can two people moving at vastly different speeds see the same beam of light moving at the same speed? The answer is uncomfortable. Something has to give. And that something is time and space itself. To keep the speed of light constant for everyone, the universe literally warps reality. If you're moving fast, your time slows down relative to the guy standing still. This is called time dilation. If you spent a year traveling near the speed of light and came back to Earth, you might find that 10 years have passed for your friends. You'd be young, vibrant, and ready to party, while your friends are complaining about their lower back pain and wondering why they don't recognize your face. And it's not just time. Space warps too. At high speeds, objects actually get shorter in the direction they're moving. It's called length contraction. If you drive a limousine fast enough toward a garage that's theoretically too small for it, for a split second, the limo would actually fit inside. Of course, the moment you stop, you've got a very expensive, very squished piece of modern art. This led Einstein to his most famous equation, E equals mc squared. It sounds intimidating, but it basically just means that energy and mass are two sides of the same coin. Mass is just supercompressed energy. This is why a tiny bit of uranium can power a city or level 1. It's also why, as you get faster, you get heavier. The faster you go, the more energy you have, which means the more mass you have, which makes it harder to go even faster. This is why you can't hit the speed of light to get a physical object to that speed. You'd need infinite energy, and the universe's credit card would definitely be declined. But Einstein wasn't done. He had a special theory, but he wanted a general one. He spent another 10 years trying to figure out how gravity fits into all this warping of time and space. Before Einstein, we thought gravity was this invisible tug of war. Newton thought the sun grabbed the Earth with an invisible rope, but Einstein realized it's much cooler and much scarier than that. Imagine a giant trampoline. If you place a bowling ball in the center, it creates a dip. If you toss a marble onto the trampoline, it'll roll around the bowling ball. Not because of an invisible rope, but because the fabric itself is curved. Einstein realized that space and time aren't separate things. They are woven together into a four-dimensional fabric called spacetime. And massive objects, like stars and planets, don't just sit in space. They curve it. Gravity isn't a pull. Gravity is just the shape of the universe. The Earth isn't being pulled by the Sun. It's just rolling along the curve the Sun creates in the fabric of space-time. And remember how we said speed slows down time? Well, gravity does too. The stronger the gravity, the slower time moves. If you spent an hour hanging out near a black hole, the heaviest, curviest things in the universe, decades could pass back on Earth. This isn't science fiction. This is literally how the universe functions. You might be thinking, okay, this is great for astronauts and guys with wild hair, but why does it matter to me? Well, do you like your phone? Do you like not being lost? The GPS satellites orbiting Earth are moving fast, about 14,000 kilometers per hour. According to special relativity, their internal clocks should lose about 7 microseconds a day compared to clocks on Earth. But wait, they are also much further away from Earth's mass, meaning gravity is weaker for them. According to general relativity, their clocks should speed up by about 45 microseconds a day. When you do the math, the satellite clocks gain about 38 microseconds every single day. If engineers didn't program Einstein's equations into the satellites to account for this, your GPS would be off by several kilometers within a single day. You'd be looking for a Starbucks and end up in a lake. Einstein is the only reason your Uber driver finds your house. Relativity also told us about black holes before we ever saw one. It predicted that light would bend around stars, which was proven during a solar eclipse in 1919, making Einstein an overnight celebrity. It even predicted gravitational waves, ripples in the fabric of spacetime caused by massive collisions, which we finally detected in 2015. So, what is relativity? It's the realization that we don't live in a world of fixed distances and ticking clocks. We live in a flexible, bendy, cosmic soup. It tells us that your reality depends entirely on where you are and how fast you're going. It's the ultimate "it depends" of the universe. It's a bit mind-bending, isn't it? The idea that time is a liquid and space is a blanket. But that's the beauty of science. It takes the things we take for granted, like the ground beneath our feet and the seconds on our watch, and shows us they are far more magical than we ever imagined. Thanks for joining us on What Is. If this video didn't make your brain undergo length contraction, go ahead and hit that like button. If you want to dive deeper into the mysteries of the universe without needing a PhD, make sure to subscribe and ring the bell so you never miss an episode. Got a topic that's been melting your brain? Drop it in the comments below, and we might cover it next. Until next time, keep moving. Just maybe not at the speed of light. Your friends would like you to stay the same age as them. See you in the next one.